Electronic warfare, or EW, is the fight over the electromagnetic spectrum. It involves using energy to control this spectrum, attack an opponent, or stop enemy attacks. This invisible conflict is a central feature of modern warfare. It determines who can communicate, who can navigate, and who can see the battlefield. In Syria, this contest has become a daily reality for United States forces. They operate in close proximity to Russian military units which have deployed some of their most advanced EW systems. Understanding this environment is fundamental to mission success and the safety of personnel. The ability to operate through a contested spectrum is a key measure of a force's effectiveness. U.S. forces rely on radios, GPS, and ISR platforms that all depend on the electromagnetic spectrum. When these systems are disrupted, a technologically superior force can find itself deaf, mute, and blind. Russia has deployed a sophisticated and layered array of electronic warfare systems to Syria. They are specialized tools designed for different tasks across the spectrum. Among the most prominent is the Krasuka family, particularly the Krasuka 4. Its primary function: jam the radar systems of airborne platforms, from J-STARS and AWACS to fighter and drone radars. By blinding eye-in-the-sky assets, it creates a bubble where aircraft struggle to see the ground. Another key component is the Borisogledsk-2, a multifunctional, mobile EW complex. It scans wide frequency ranges, identifies enemy radio networks, then jams them. Breaking links sows confusion and degrades coordination and response. For smaller communications, Russia uses the Lear-3, combining EW with UAVs. It suppresses cellular networks, can imitate towers, send false texts, and locate users. Krasuka, Borisogledsk-2, and Lear-3 combine to tailor control of the spectrum. For U.S. forces, the threat is persistent and multifaceted, from strategic reconnaissance to a single soldier. One of the most frequent effects in Syria is the jamming of communications. U.S. forces depend on reliable links to coordinate movements, call for support, and maintain awareness. Russian systems specifically target these links. Effects can be immediate and disorienting. Digital data links with nearby units and aircraft can become intermittent or fail. Units fall back on less efficient methods, slowing operations. Small mobile patrols reported disruptions to encrypted tactical radios correlating with proximity to Russian and regime forces. Some links were unusable for extended periods. This jamming forces changes in behavior. Less reliance on constant comms, more autonomy, higher risk. Disruption goes beyond voice to critical data links. A targeting link to a close air support aircraft can be jammed, complicating ID near friendlies. If leaders cannot talk, they cannot direct the fight. If intel updates stop, situational awareness collapses. Operational tempo slows, creating exploitable windows. This has driven decentralized command and comms-denied training. Beyond comms jamming, Russian EW frequently targets GPS. GPS provides positioning, navigation, and timing for soldiers, vehicles, aircraft, and weapons. Jamming overpowers the weak satellite signal, causing receivers to lose lock. Spoofing is deceptive. False signals trick receivers into wrong position or time. Troops must fall back on traditional land navigation, skills that can be perishable, especially in featureless desert or at night. A frequently cited case: devices at Tanf showing location as Khmeimim Air Base, hundreds of kilometers away. Spoofed data risks misdirected fires, undermining GPS-guided precision and safety. Aircraft might think they've strayed into hostile airspace, escalating tensions. Reports note unreliable navigation near the Syrian coast. GPS timing synchronizes networks. Disruption can break encrypted radios and data links. U.S. forces must cross-reference multiple methods, never fully trusting automation in contested zones. Constant vigilance is required to know where you are, where you're going, and what you can rely on when satellites lie. Drones are a cornerstone of U.S. intelligence, surveillance, and reconnaissance in Syria. They provide persistent overwatch, watching movements, identifying threats, protecting convoys. From small tactical drones to high-altitude MQ-9s, all rely on spectrum. They depend on data links for video and sensor data, and GPS for navigation. Systems like Krasuka can target satellite communication links, causing video loss. or even loss of control. When command links sever, drones revert to pre-programmed procedures, aborting missions. U.S. officials confirmed Russian jamming has cut short surveillance missions. More aggressive interference has been suspected in the loss of smaller tactical drones. Intense jamming or spoofing can confuse navigation enough to destabilize flight. Disrupted ISR degrades situational awareness and decision speed. Tracking fighters, spotting IEDs, and warning of ambushes all become harder. Operators fly less predictably and vary altitudes to mitigate threats. This drives hardening and alternative navigation. Key areas of U.S. development. Persistent Russian EW creates a cascade of operational risks for U.S. forces. Loss of command and control at small unit level is immediate and dangerous. In combat, inability to call reinforcements, medical evacuation, or fires can be catastrophic. Units may be forced to fight with only what they have on hand. Situational awareness shrinks. Fog and friction grow. Poor information invites ambush and missed high-value targets. Safety risks extend to military personnel and civilians. Spoofing can lead units into minefields or enemy engagement areas and increase friendly fire risk. A less advanced adversary can level the field by negating key advantages. Units must be ready to operate degraded, relying on basic soldiering skills. Operational tempo slows, risk calculations change, margins shrink. Syria warns that future conflicts with peer adversaries will be fought where the spectrum is not permissive, but contested. U.S. forces are mitigating the EW threat with hardened equipment and smarter tactics. Advanced radios hop across thousands of frequencies per second, resisting jamming. More resilient GPS receivers add anti-jam tech and military-only signals. These hardware layers make critical systems more robust. Beyond tech, units practice MCON, minimize signatures and transmissions, use directional antennas and only transmit when necessary. Signals intelligence provides electronic early warning where and when jammers are active. Units switch to alternate methods and rely on pre-planned routes to navigate contested areas. Routine GPS-denied training refreshes fundamentals, building resilience from the individual up. More dispersed, decentralized tactics empower junior leaders to act with limited comms. Technology plus TTPs plus rigorous training. The formula for success in a contested spectrum. In Syria, Russian EW actively degrades U.S. command, navigation, and surveillance, forcing rapid adaptation that will shape how America fights the next war.